we're trying to derive scenarios wherein we have friction and the amount of additional work that we need to do against the friction. Actually, additional work that we need to know because of friction. That's the right phrase. So guys, the most easiest and the most used formula when it comes to work is nothing but force into displacement. When we were kids, around 2-3 years back, not for me, for you guys would ever use this. Force is equal to, sorry, not force is equal to, work is equal to force into displacement. So this is something that we are going to make use of it. This is coming ahead of time. So that is something that you guys have to remember. So now the first case is we have to work. So the work done in moving a body along the horizontal. So let's consider an object. Mass M. Let me write it here itself. Right? Therefore, its weight will be, I hope you guys know the difference between mass and weight. This is the difference. And from here and normal reaction, that's a normal force. R will be equal to M into G, right? So we are looking at a surface, we are looking at an object, and the object is not here. Since we have to move it, say it's over here, and we move it. As and when we move it, we encounter friction. That's what we are trying to figure out. So the distance from point A to point B is, say, S. And we have the normal to be R. And yeah, all along the way, what is there? Friction. Fk. In this case, it's kinetic friction. And this is your mg, because of which we have the reaction. And yeah, this Fk happens because of the force that we act on the object F. Right? So let's talk about, let's consider force of F is applied and applied parallel to the surface. Surface, that is the ground actually. In this case, it's the ground. Then we'll tell the force F is just enough to, it's similar to the derivation that we did with kinetic energy and potential energy in our previous grades when you guys were kids, again 2-3 years back. The force is just enough to slide the object. Now let Fk be the kinetic friction, that is friction that arises when the object is already moving. Therefore, the work done by the force F will be equal to force into displacement, and in this case, force is equal to Fk. This from the statement 1. Fk is equal to F. So because of from 1. Okay, so we had force is equal to, work done by force is equal to force into displacement, and in place of force we are representing with Fk, because F and Fk are equal. This is from 1 because of this statement. They're approximately equal. Right? And on substituting, Fk is equal to mu k into the normal reaction. In this case, it's R. You can write N also. That's left to you guys. So therefore, the work in moving a distance of S is mu k into R into S. And that's your answer.